You want to bite?
No.
That looks good.
Is it okay if I have this in here?
Yeah, I don't care.
Okay, thank you. Yes. I have to pay back because I don't have any money.
So I turn it in from the book, and I realized that I forgot to do the ones
Okay.
like on the one that I found.
Okay, just put it in the inbox then.
All right.
You'll be late, but yes. You had all lunch. Okay, before we get started, if you guys didn't get those assignments turned into Google Classroom, this is your last chance to still get full points on them. That would be 37, 38, and 42. So if you need to double check, then please do. Our quiz this morning is no calculator. So once you get your stuff turned in, if you need to, and your phones, smartwatches put away at the side of the room, I will get you the quiz to let you get started. I believe so. I believe it's worksheet 1, worksheet 2, and worksheet 3. Okay, did I skip anybody because your desk was not cleared off? Okay, question 1, before you guys get too deep into this, is matching. So notice below the little table, there's choices A through I. I guess you're welcome to write out the full answer, but I would prefer if you just put the letters. I think that's easier on you and me. But if you write the whole thing out, that's fine too. I can read it that way. Question 2, all of those parts are worth 2 points each. So in addition to getting the right answer, you should try to show some work. try to show some of your thought process in case your final answer is off, you might still be able to get a point. Same with question 3 and 8 and 9. The other questions, multiple choice and matching, there's no partial choice on it, so. So please make sure your name is on it, and you probably should number it 44 so you know where it goes in your binder when you get it back. And then finally, as you guys turn your quiz in, I do have the 4.8 handout for you to grab while you're up here. And we'll look at it as a group when all the quizzes are in. Normally, if you turned in a hard copy of your homework, I would ask that you pick it up by your phones when you're done in that box. But Grade Viewer or Gradebook is not working right now, so I can't put those grades in, so I can't have you pick them up yet. So I may not be able to get your homework back to you yet today, but I'll keep checking it.
Thank you. Aaron. Is anybody still working? It's fine if you are. I just can't tell. Okay, let's go ahead and move on then. So I don't have all of your homeworks graded because gradebook was down. It did finally come back up, but I haven't had time to do that since. So you'll have to be a little more patient than normal there. Also, I had a handout for you guys to pick up as you turned your quiz in. If you forgot, just raise your hand and I'll bring it to you.
Anybody else? Okay, this will take just a couple minutes here because again, you have seen most of the stuff that you need to know about section 4.8. And if you notice on the homework section of the agenda, I am asking you to get through questions 1 through 15, but we're going to do several of these together just so you know what 4.8 is about. So when we started this third unit, I had mentioned that 4.7 was definitely the harder part of this unit, at least for most people. So if you're feeling pretty good about 4.7, then you should be fairly close to being ready for your third test. But there is a tiny bit of review and a tiny bit of new stuff in section 4.8. So questions 1 through 7 are all the notes that we need to do. And then we'll look at question 8 as an example and question 11 as an example. And then I'll ask you to do the rest of 1 through 15. So, section 4.8 is really about finding side lengths of right triangles, which you've been doing with Pythagorean theorem and SOHCAHTOA equations, and finding angles of right triangles, which you've been doing since geometry and with inverse SOHCAHTOA. And that's pretty much the bulk of section 4.8. But you need to make sure that you are aware that uppercase letters represent angles, whereas lowercase letters represent sides. Angle A is always opposite side A, angle B is always opposite side B, and angle C is always opposite side C. So when you're given information, you know where it goes. I've been pushing this for a little while, but a quick way to make sure your answers are realistic: if the biggest side is opposite the biggest angle, and the smallest side is opposite the smallest angle, then that also guarantees that the medium-sized side would be opposite the medium-sized angle. Now, that doesn't guarantee that our side lengths and angle measures are correct, but it does mean that if that's not true, then it does guarantee that they are not correct. So that's a quick 5-second check that we can do at the end of these. The review piece, and honestly this is one of the harder things for students in this section to see, but not questions 1 through 15, not the ones I'm asking you to do between now and Tuesday, but some of the very end ones that we'll do in class on Tuesday. You need a tiny bit more information. You need one more angle and a spot that they don't give it to you in those word questions. So you need at least to remember what alternate interior angles are. If you remember any of these others and you remember how to apply them and how they work, then that's fine too. But the one I'm going to focus on is alternate interior angles. So when you have two parallel lines cut by a transversal, transversal just means a line that intersects two or more lines. The interior, the I, means inside the two lines. So I'm only interested in these angles, which I'm going to name 1, 2, 3, 4. Those are the interior angles. And the ones that alternate are considered alternate interior angles. So like angle 2 is in the top left of the interior. Angle 4 is in the bottom right of the interior. Top left with bottom right, those are alternate interior angles. Likewise, angle 1 and angle 3. Angle 1 is in the top right. Angle 3 is in the bottom left.
so those are considered alternate interior angles. So when you have two parallel lines, alternate interior angles are congruent. So if you knew how big angle 2 was, you need to know that angle 4 is the same size. If you know how big angle 3 is, you need to know that angle 1 is the same size. And even though, of course, my sketch here is a terrible sketch, it's far from being actually parallel, it still kind of makes sense. If you just eyeball angle 1 and angle 3, you should see that those two look like they're the same size, and 2 and 4 look like they're the same size. But again, if you remember what alternate exterior angles are and you prefer to use those on Tuesday, that's fine. If you remember the relationship between same side interior, those are not congruent, those are supplementary, but you're welcome to use those. You're also welcome to use corresponding angles. But the one on Tuesday that I will be using, because this is the only one that you have to have for us in this class, is alternate interior angles. So that'll come up, so we'll need to refer to that. And then really the one new thing in this section is a different way to describe angles. So when we've talked about angles thus far this year, we've always assumed we were in standard position, which is start at the positive x-axis, turn counterclockwise if your angle's positive, turn clockwise if your angle's negative, but that's not the only way to do angles. So another way to do that is something called bearings. Bearings are really popular in real-world questions, so our application questions we're going to do on Tuesday, because I think all airplane navigation and all boat navigation uses bearings. So for these questions, I'm going to pretend like I am on point C and the bearing is giving me directions to go to point A, just to have some points to talk about. So if I'm standing at point C and I want to take a north 30 degrees east bearing to get to point A, what you need to do is from point C, you're going to start on this line. So the N for north, that's the line we're going to start at. Then we're going to turn this much towards this line. So starting at the north line, I need to turn 30 degrees to the right, because to the right is east. So this would be the bearing to head towards A, where this angle would be 30 degrees. You turn 30 degrees away from the north line towards the east line. So these aren't too bad because it basically gives you the directions that you need. The second one wants us to take a bearing of east 20 degrees south. So assuming we're starting at point C, if I started measuring at the east line and turned 20 degrees towards the south line, then my path would look like this, where I just turned 20 degrees. And if that is a bearing from C to A, then I'm starting at C and heading to A. That's the directions to head to A. Make sure you're putting these angles where they go. The angles are the important part. Okay, so south 45 degrees west would mean from the south line, you should turn 45 degrees towards the west line. So that would be 45-degree turn. And we would call that a bearing from A to C if you were starting at C and trying to head towards A. Okay, before I do the last one, I would like you to try to draw a picture of this bearing, what you think it's supposed to look like, so you have a quick check. Try to draw a bearing of west 15 degrees north. Name your starting point C and your ending point A. Okay, if you're struggling, just make C your kind of your starting place. Go ahead and just make a north, south, east, and west. You can just draw in all of them, but you should have started towards west and turned 15 degrees up or down. Up towards north. So if you're turning 15 degrees up, that means this angle was 15. That angle was 15. And so your bearing should look something like that. And of course, if you know that this is 15, the reason why that's important to label it, you will also know that this would be the complement of 15. This would be 75 if you needed to know it. I guess you would know, you could figure out how much all of this is if you needed to know it, because you know that all three of these make up 180, but it gives you something to start with. So that is really the only completely new thing in this section. So any quick questions about bearings? Okay, so this geometry review, alternate interior angles, and using the bearings, again, this is not going to show up on questions 1 through 15. The 1 through 15, the ones I want you to do are ones that you should already be able to do. So the last two we'll talk about together, just to give a couple quick examples, is going to be 8 and 11. On question 8, I give you 2 angles and 1 side, and you should be able to solve that right triangle, which means find all the missing stuff. Find all the missing angles, find all the missing sides. So we need to summarize this into 4 tools that we need to have. You probably want to label your triangle with the numbers too. If A is 20 degrees and C is a right angle, then how big does angle B have to be?
70.
Okay, how'd you do that so fast?
I just added 20 to, like, what makes 20 90? Then 90 plus 90 equals 180.
Okay, so knowing all 3 angles of a triangle add up to 180 is a nice, easy way to find the last angle. So that's one of your 4 things you need to be able to do. You've been doing that one since geometry. Okay, I also need to find side A and side C. I would like to find side A with Pythagorean theorem. Can I do that? How come?
There's only one side.
For Pythagorean theorem, you need 2 sides. So, the 180 trick is one of 2 things you need to know for angles. Pythagorean theorem is one of 2 things you need to know for side lengths. But you can't always use Pythagorean theorem. Sometimes you don't have enough information. The second way to find side lengths is with a SOHCAHTOA equation. You could say from 20, I'm trying to find opposite when I know adjacent. So that could be tangent. A is 10 times the tangent of 20 degrees. Of course, your calculator needs to be in degree mode, and it hasn't been in degree mode for a few weeks, so make sure that you change that. Okay, now that I have 2 of 3 sides, I could do Pythagorean theorem. You should not be using this rounded amount. You should be using all 8 or 9 decimals in the calculator, or using the store button. Or, even better than that, even though I think you should feel pretty confident, what if I wanted to do another SOHCAHTOA equation, and maybe this time I'll do cosine, because I know from 20, I know adjacent, and I'd like to know hypotenuse. So if you can do a SOHCAHTOA equation to solve for side A, you should also be able to do a SOHCAHTOA equation to solve for side C. And if you have all of the numbers written on your picture, the 5-second check to make sure your numbers are at least realistic. The biggest side has to be opposite the biggest angle. By the way, do you guys know why the hypotenuse has to be the biggest side? a triangle has a right angle, that's guaranteed to be the biggest side or biggest angle, right? So if 90 degrees is the biggest angle, opposite has to be the biggest side. That's why your hypotenuse always has to be the biggest. And do a quick check to make sure your small side's opposite your smallest angle. If either one of those are not true, then you know something is wrong. If both of those are true, then you can have a little bit of confidence in your answer. The one last thing I want to say about this question is even though I could have done Pythagorean theorem instead of a SOHCAHTOA equation, the reason why you might want to do both of them SOHCAHTOA is then you could check with the calculator, you could check with Pythagorean theorem. You could make sure that your a squared plus your b squared is equal to your c squared. And I just did that in my calculator and it looks fine. So any questions about 8? Okay. Sometimes subtract from 180 to find the last angle, sometimes SOHCAHTOA to find the last side. Okay, skip down to 11 because it's one that has different information. So just because you could solve number 8, number 11 has different tools. Okay, so this time we don't give you 2 angles and 1 side, we give you 2 sides and 1 angle. Again, that changes the dynamic, it changes what tools you can use. So on question 8, to find an angle, we subtracted the 2 that we had from 180 to find the last one. I can't do that here. I got 2 sides. So what's the only other way to find an angle like angle A?
Solve for the hypotenuse.
Sorry?
Solve for the hypotenuse.
Okay, but I'm interested in angle A, not the side.
Tangent theta.
Okay, tangent. Do you want to find side A or angle A or angle B first? It doesn't matter, but okay, so do A. So tangent of A would be his opposite to his adjacent. You guys agree with that tangent or that SOHCAHTOA equation? But to go from, I don't care what tangent A equals, I'm interested in how big angle A is. So how do I go from tangent A equals to just A equals?
Divide by tangent. Inverse.
You can't divide by tangent. It's not tangent times A, it's tangent of A. They get stuck together.
Inverse tangent.
Very good. Inverse tangent. So if you can only do the 180 trick, then you're not going to be able to get all the angles. Sometimes for angles you have to do inverse SOHCAHTOA. So inverse tangent if you have opposite over adjacent, inverse cosine if you have adjacent and hypotenuse, and inverse sine if you have opposite and hypotenuse. But that gives us about this. Now, once again, now that I have 2 angles, I could subtract those from 180 to find the third one, and there's nothing wrong with that. But it might be good practice for you to make yourself do the other angle with inverse SOHCAHTOA as well. Angle B is also inverse tangent. Inverse because we're trying to find an angle. Tangent because we have opposite and adjacent. But notice this small little difference to find angle A to angle B. From angle A, his opposite was 6 and his adjacent was 16. But if you're looking from angle B, 16 is the opposite and 6 is the adjacent. So I'm almost typing the exact same thing in my calculator on both of those, but not exactly the same, just very close. Now, the benefit of doing both of these with inverse SOHCAHTOA instead of doing one of them with inverse SOHCAHTOA and the third one from subtracting the other 2 from 180 is you've got an extra check now. You know all 3 of these are supposed to add up to 180, right? So I've got a calculator in front of me. I can add angle A to angle B to angle C, and it does add up to 180. So that's the benefit of doing SOHCAHTOA twice, but you've got to at least do it once. You don't have enough information to find all the angles without inverse SOHCAHTOA. Okay, and then you've got lots of options for side C. You've got some of these acute angles. You could look from angle A or angle B. You could use the 16 or the 6, and you can make a SOHCAHTOA equation to find side C. That's what we did in question 8. Or, if you would rather, you know 2 of 3 sides, so feel free to throw those in Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared, and that comes out to be about 17.088. Okay, and if you throw all those answers where they're supposed to go, it takes you 2 seconds to make sure that the smallest side is opposite the smallest angle, and the biggest side is opposite the biggest angle. Just a quick way to make sure your answers are realistic. So, there's 4 things you have to be able to do. You've got to be able to do 2 for sides and 2 for angles. One angle trick is subtracting 2 from 180 to find the third. But if you don't have 2 angles, you have to do inverse tangent, inverse sine, inverse cosine to at least find 1 angle. And then you could do whichever you wanted for the third side. For the sides, the 2 things you need to be able to do is Pythagorean theorem, but that only works if you have 2 sides. If you only have 1 side, you have to do at least 1 SOHCAHTOA equation. So SOHCAHTOA equations to find sides, Pythagorean theorem to find sides. Inverse SOHCAHTOA to find angles, subtract from 180 to find angles. Those are the 4 things you need. 2 ways to find angles, 2 ways to find sides. Okay, any questions about 8 or 11, the 2 examples I did with you? Okay, then please go ahead and finish up through question 15. So you really only have 9, 10, and 12 through 15. Those are either the generic triangle ones or very basic word questions. So do those and check your answers with the website before next Tuesday, because if something's holding you back on those, the same thing's going to hold you back on the later questions as well. So we need to iron that out instantly on Tuesday. Another thing to keep in mind is that we don't spend too much time in section 4.8. This handout that you have is the notes, the examples, the practice, the homework, all of it. We don't have any other worksheets. We don't have any other book assignment. So by doing questions 1 through 15 and check-in, you should make sure that you're good with the basics, and then we can focus on a couple harder word questions on Tuesday. Okay, I'm going to turn the screen off, but of course, if something's not working out and you want some assistance, just call me over to your desk or bring it up here to me. Whichever one's easier for you.